Above our planet, beyond the clouds, the universe stretches in every direction, filled with billions of galaxies, each carrying billions of stars. Even in the darkness between stars, matter drifts in silent, slow motion, tracing paths determined by gravity. The Milky Way alone contains perhaps 100 billion stars, many with orbiting planets, each spinning quietly, maintaining their own rhythms for millions or billions of years. Some planets are small and rocky, some giant and gaseous, and each exists in a delicate balance, orbiting in predictable paths, sometimes in harmony, sometimes in slow, subtle eccentricities. Imagine the invisible lines that govern these orbits, unseen forces moving every mass in silent precision. The stars themselves are diverse, each with its own life cycle. Some, like our Sun, burn steadily for billions of years, converting hydrogen into helium through nuclear fusion in their cores, producing light and warmth that reaches distant worlds. Others are massive and short-lived, exhausting fuel rapidly, expanding into red supergiants before ending their lives as supernovae. These explosions scatter elements such as carbon, oxygen, and iron into space, the building blocks of future stars, planets, and even life. The universe recycles itself in these cycles, quietly and patiently, without hurry. As you imagine these processes, consider the scale of time involved. Stars live and die on timescales that dwarf human history. The light from some stars you can see tonight began its journey millions of years ago, long before humans walked the Earth. When that light reaches us, it is a record of the past, a gentle signal crossing space, uninterrupted, carrying with it the history of the cosmos. Some stars are so distant that their light we see today may arrive after traveling across vast stretches of intergalactic space, slowed and stretched by the universe's expansion. This expansion also shifts light to longer wavelengths, a phenomenon known as redshift, allowing astronomers to measure how far and how fast galaxies move away from each other. Beyond individual stars, galaxies themselves are diverse in shape and size. Spiral galaxies, like our Milky Way, rotate with stars moving in coordinated orbits around a dense central bulge, creating grand, sweeping arms where star formation is ongoing. Elliptical galaxies have stars in more randomized orbits, older, more stable, with less gas and dust for new stars to form. Irregular galaxies, often small and disturbed, reveal the traces of past collisions and gravitational interactions, quietly reshaping over billions of years. Some galaxies collide, merging slowly in a ballet that unfolds over millions of years, stars passing near one another without direct collision, gravity reshaping their paths, creating bursts of star formation as clouds of gas compress and ignite. Within galaxies, clusters and superclusters organize matter on even larger scales. Gravity binds hundreds or thousands of galaxies together in clusters, which themselves may form superclusters spanning hundreds of millions of light years. Between these massive structures lies vast cosmic voids, regions nearly empty of galaxies, where the density of matter is extremely low and the darkness is deep. The universe's large-scale structure resembles a vast web, with filaments of galaxies stretching across space, connecting clusters, leaving enormous voids in between. The distribution is not random, but shaped by subtle fluctuations in density from the early universe, magnified over billions of years by gravity. Among these structures, the smallest details can hold fascination. Nebulae, Clouds of gas and dust glow softly under starlight or absorb it, forming dark silhouettes against brighter backgrounds. Some nebulae are stellar nurseries, where gas collapses under gravity, fragments into cores, and ignites nuclear fusion, forming new stars. Others are remnants of dying stars, their expelled material drifting through space, forming intricate filaments and wispy shapes that can span dozens of light years. The colors, often captured in telescope images, though sometimes enhanced, originate from specific elements. Hydrogen emits red light, oxygen emits green or blue, and other elements contribute subtle hues, all following the rules of atomic transitions. Stars are not alone in their immediate surroundings. Many have planetary systems, moons, rings, and asteroid belts, all moving under gravitational guidance. Some planetary systems are highly organized, like our solar system, while others are chaotic, with planets in elliptical orbits or migrating over time due to interactions with gas and other planets. Exoplanets, discovered through transits or radial velocity measurements, reveal an astonishing variety. Some are gas giants close to their stars, others rocky worlds in habitable zones, some orbiting two or more stars simultaneously. The diversity illustrates the natural variability of formation processes, yet all obey the same fundamental physical laws that govern motion, gravity, and energy. Gravity also governs other remarkable phenomena. Black holes, regions where space-time curves so sharply that nothing can escape, quietly dominate the centers of most galaxies. Their presence is inferred from the motion of nearby stars or the behavior of gas swirling into them. The supermassive black hole at the center of the Milky Way, for example, has a mass millions of times that of the Sun, yet its gravitational pull is gentle at the distance of our solar system. Even extreme objects like black holes fit into the grand pattern of motion and energy in the cosmos, following predictable laws described by general relativity. Between stars, interstellar space is not empty. Tiny dust grains, sparse gas atoms, and cosmic rays drift slowly, barely interacting. Yet over millions of years, this sparse medium can form molecular clouds, the seeds of future star formation. Cosmic rays, high-energy particles accelerated by supernovae or active galactic nuclei, travel through the galaxy, sometimes colliding with atoms, producing secondary particles and radiation. Even in apparent emptiness, space hums with subtle processes, a quiet background of constant activity that continues without interruption. The universe also expands on the largest scales, driven by dark energy, a phenomenon that accounts for roughly 70% of the total energy content of the cosmos. This expansion stretches space itself, moving galaxies away from each other at speeds proportional to their distance. Over billions of years, this expansion affects the light reaching observers, alters cosmic distances, and influences the fate of the universe. While invisible and subtle in day-to-day life, it governs the evolution of cosmic structures and the pathways of light and matter across immense scales. Stars undergo nuclear processes at their cores that are both predictable and mesmerizing. In smaller stars, hydrogen fuses into helium via the proton-proton chain, releasing energy that balances gravitational compression. In more massive stars, the CNO cycle dominates, using carbon, nitrogen, and oxygen as catalysts to convert hydrogen into helium. As stars exhaust their fuel, they evolve into red giants, shedding mass slowly or explosively, enriching the interstellar medium with heavier elements. These cycles, though violent in energetic terms, occur over such timescales that from a human perspective, they are calm, slow, and steady. As these processes unfold, light from distant stars provides a detailed record of stellar interiors. By studying spectra, astronomers can determine composition, temperature, density, and even subtle motions within stars. A tiny shift in spectral lines reveals rotation speed, turbulence, or the presence of orbiting planets. Every photon carries information, a tiny messenger from across space and time. The cumulative effect of billions of photons allows humanity to map galaxies, measure cosmic expansion, and understand the life cycles of stars with remarkable precision. In this immense structure, there are also pulsars, highly magnetized, rotating neutron stars emitting beams of radiation. Their rotations are incredibly stable, some varying by less than a millisecond over decades, effectively acting as cosmic clocks. By measuring the timing of these pulses, scientists study gravity, test relativity, and even map interstellar space. The regularity of these pulses contrasts with the apparent chaos of cosmic events, revealing a hidden order that pervades the universe. As you drift among these thoughts, consider the faint background of cosmic radiation, left over from the earliest moments of the universe. This relict radiation permeates all space, nearly uniform, but with tiny variations in temperature that indicate the initial seeds of structure. By mapping these fluctuations, astronomers reconstruct the formation of galaxies, the distribution of dark matter, and the evolution of cosmic architecture over billions of years. The fact that such ancient signals persist, traveling across the universe to reach us, is a subtle but profound reminder of the continuity and calm persistence of natural law. Even in regions of space dominated by apparent emptiness, subtle forces continue their work. Magnetic fields thread through interstellar space, shaping the motion of charged particles, influencing the collapse of gas clouds, and guiding cosmic rays. Radiation pressure, the force exerted by light itself, can drive gas away from stars, shaping nebulae into intricate forms. Each of these processes, while powerful, unfolds slowly over timescales that allow space itself to appear tranquil and steady. Galaxies, clusters, and superclusters also interact through gravitational attraction, often producing tidal forces that stretch and distort stars and gas over millions of years. These interactions lead to the creation of tidal streams, bridges of stars connecting galaxies, and can trigger new waves of star formation. Even collisions on this scale, though energetic, are imperceptible in the short term and unfold with a majestic slowness, a cosmic dance that requires patience measured in eons. As your breath continues, imagine yourself floating between stars and galaxies, silent, weightless, witnessing light that has traveled hundreds of millions of years to reach this moment. The universe hums with subtle activity. Fusion in stellar cores, the orbit of planets, the slow rotation of galaxies, the whisper of cosmic radiation, the gentle tug of gravity. Nothing demands haste, nothing presses, all moves according to timeless principles of physics, rhythmically and predictably. Within our own solar system, planets spin in elliptical paths, moons orbit planets, and distant dwarf planets follow long, curved trajectories. Some regions, like the asteroid belt or Kuiper belt, contain countless small bodies, tracing orbits almost undisturbed for billions of years. Occasionally, gravitational perturbations nudge one into a new path, but most drift in silent stability. Comets, icy travelers from the outer reaches, carry material from the early solar system, offering clues about its formation and composition. Each element, each particle, moves according to natural law, forming a calm, enduring system. The Sun itself, a medium-sized star, provides the energy that sustains life on Earth. Its light, traveling at 299,792 kilometers per second, reaches our planet in about 8 minutes. The sun cycles through periods of magnetic activity, with sunspots, flares, and coronal mass ejections. Yet these events unfold with a rhythm that repeats over decades. The steady rise and fall of solar activity is yet another reminder that even dynamic processes in the universe possess long-term patterns and predictability. As your mind grows heavier, let your awareness expand to include other cosmic phenomena. Interstellar dust, though sparse, absorbs and scatters light, shaping the way we see distant stars. Cosmic neutrinos pass through matter almost without interaction, silent messengers from the nuclear reactions in stars and supernovae. Gravitational waves ripple through space-time itself, created by the most violent events like colliding black holes, yet traveling vast distances quietly, detectable only with sensitive instruments. Even the universe's most dramatic events unfold in a vast theater where nothing is rushed. And so, floating among these vast processes, you may feel your own smallness, yet also a calm connection to everything. The cosmos operates on scales beyond worry or haste, governed by unchanging laws. Each star, each planet, each galaxy moves in predictable ways, their motions measurable, understandable, and serene. The universe offers a perspective in which our everyday concerns are brief, fleeting, and unnecessary in this moment. There is nothing to do but observe, imagine, and drift. Even as the universe continues to evolve, forming new stars, merging galaxies, and expanding space, there is a constant background of stability. The laws of physics remain predictable and consistent. Energy and matter move in elegant patterns. Forces interact in ways that maintain overall balance, creating a cosmos that is both dynamic and calm, vast and orderly. Let this order settle in your mind, drawing your thoughts into quietness, your body into stillness, your breath into slow rhythm. As you lie in the dark, with eyes closed and body relaxed, the universe's gentle rhythms mirror your own inner state. Light from distant stars and galaxies reaches you slowly, almost as if in conversation across time. Gravity's quiet pull, the slow rotations, the cosmic expansion, all proceed without urgency, without tension. Your mind may now join this cadence, syncing with the cosmos's patient motion. In this space of thought, imagine drifting ever farther, beyond your room, beyond Earth, beyond the solar system, past neighboring stars, past distant nebulae, past entire galaxies. Everything is still, silent, immense. Your breathing is slow, your heart steady, your mind calm. The universe is vast and eternal, yet you are part of it, quietly, gently, without disturbance. Let your thoughts dissolve into this calm expanse. Stars, planets, galaxies, and radiation all move predictably, governed by forces as ancient as time itself. There is no haste, no urgency, no demand. The universe, in its immensity and patience, becomes a lullaby, a slow rhythm guiding you toward deeper rest, toward sleep. Your mind drifts, your body relaxes, light years stretch across the universe, silent and undisturbed. Nebulae glow faintly, clusters move in harmony, black holes bend space without sound. All unfold according to the serene laws of physics. You are weightless, calm, drifting in space, enveloped in the vast, timeless rhythm of the cosmos. And now let your breathing match the rhythm of the stars, the rotation of galaxies, the quiet pulse of the universe itself. Inhale slowly, exhale softly. Let every thought dissolve, every tension fade. Sleep approaches gently, carried by the calm, eternal motion of the universe, by the steady glow of distant stars, by the silent, patient dance of cosmic structures. Drift now. Rest. Sleep.